Okay, hi everyone. So today I'm going to be showing you how to make this, which is basically a 3D model of your site. It has contours elevated to the right exact level, which I've used to make a surface from the contours. And then I've also added buildings to the accurate elevation as well as to their accurate height. And we're going to be making this using Grasshopper, which is an extension of Rhino. Now, I just want to be clear that this is not at all mandatory. You don't have to build this from scratch. I don't even think you have to use this at all. This is just if you want to. I'll also provide the script here so you can just kind of plug in your files, and I'll show you how to download the files that you'll need. You don't have to build this from scratch, but I thought we would film this tutorial just to go through it if anybody wants to. So with this model, then you can use this to make your sections. So you'll have accurate buildings and you don't have to look at them and try to measure them off of Google Earth. And you'll have somewhat accurate elevational data in terms of what the section line will look like over the landscape. So I'm going to do a basic interface for Grasshopper. I am not at all an expert, so I'm not going to go through it fully. I don't even know half the capabilities that Grasshopper has, and I definitely can't go through a ton of explanations because I don't fully know how they work. And I also just don't want to get too crazy with it. This is just going to be a super basic script. As you can see, there's like 6 components, for one thing. So we're going to keep it simple. So this is obviously Windows. I'm using Boot Camp on my Mac, which is basically where you can partition your hard drive and use a certain amount for iOS and a certain amount for Windows. So if you have a Mac, I recommend either getting Boot Camp. It's not that hard to set up, or phone a friend and ask them if they can help you out with it. Maybe meet them at school to do it together. Or you can ask me. I can try to help you out if I have time. Next, you'll also need some plugins. I'm going to put the link for where you can download the plugins somewhere in the description of this video, and I might make a separate tutorial on just how to install the plugins into Grasshopper. Okay, so jumping into Rhino, I've opened it. I'm just going to open the default here. So I'm going to use about half my screen here, since Grasshopper I'm going to put on the other side, and I'll show you how to enter into Grasshopper right now. I'm already in meters somehow. I might have clicked the meters template. And you're basically just going to type Grasshopper. It takes a second to load up here. Okay, so this is Grasshopper. It's basically an empty canvas where you can type in components, which are basically like commands that are going to do an action right into your Rhino. Now, nothing that you put in the Grasshopper window is going to actually exist in Rhino until you do this thing called baking. Baking is basically when you bake the geometry into a physical form that then you can edit in Rhino. So for example, to do a command or a component, you can double click on the canvas and type in whatever it is that you're looking for, or you can find it in all of these menu bars. So if I'm going to type circle, it says that it needs a plane and a radius. Here we have the base of our circle. It's automatic. When you hover over the component or you click on it, it turns green. When you're not selecting it, it's red. So if I give it a radius, I'm going to double click on the canvas and give it a number. We're going to use a number slider. You can either type number slider, or you can just double click and enter a number. You can just delete whatever you're not using, and I'm going to plug that into radius. So with the number slider, you can slide this, and you can also make a different plane, but that's basically how Grasshopper works. It needs things to plug in, and it's going to give you an output. If I wanted to manipulate the circle in Rhino, I'm going to right click and I'm going to press bake. You can choose what layer to bake it on, press OK. And then as you can see, it is editable, and you can still use this component, but it already has baked the geometry into Rhino. If I'm done playing around with this, but I need to keep it running because it's part of a longer chain, what I would do is press the scroll wheel on my mouse and this little disable preview button. You can click that and it's going to turn off the preview of this component, although it is still running. To stop it from running, you can do the same thing, scroll wheel click and press disable. And that's going to stop it from running. As you can see, it's grayed out. Okay, so what we're going to start with is getting in our files. We're going to be using two separate files. One is going to be of the contours, which we're going to use then to make our mesh for our ground surface. And then we're going to use the building data from the City of Vancouver Open Data Portal. So we'll go through that. So you're going to pull up the City of Vancouver Open Data Portal. It's just opendata.vancouver.ca. And we're going to search for a data set here. We're going to search for contours. Now I'm going to use the elevation contours 1 meter. That means that it's a 1 meter interval in between each contour elevation. If you go to the table here, you can see that there's all of this data that the City of Vancouver has. But we're just going to export a small snippet based on a site that we're going to choose now. So I'm just going to do a really small site near where I live, and I'm going to use this square. Oh, see, it takes a second, but these are all the contours that they have. And I'm going to use this rectangle to draw a little square around what I want to export. So I'm just going to do, maybe I'll do more of Jericho here. Okay, so I'm going to use that. It's pretty small, but we're going to go with it. Next, we're going to go over to export. And the very, very important thing to do here is to switch these geographical coordinates to EPSG 26910. You have to use this one every time. If you accidentally don't switch it, your file is going to be way off in the middle of nowhere. You really want to make sure that you're using this one. Then we're going to download a shape file, but we're only going to use the 25 selected records that we used in our polygon. So we're going to press only the 25 selected records and just wait for that to download. Okay, so once it's in our downloads, you're going to right click on your folder, go to properties and just unblock it. I don't know why you need to do that. That's not a thing on Mac, but that's a thing here. And then we're going to extract all of these. You can just leave it in your downloads, or you can move it to a folder where you have all of the files. I'm pretty lazy and I just leave it in my downloads because I don't really need to use it ever again after right now. Okay, so we're done with the downloads. Now that you know where it is, we're going to start with our Grasshopper script. Okay, and I'm going to work in top view for now. So with the plugin that we downloaded, we're going to use a few of those components, and we're going to start with a read shape component. So I'm just going to type in read and it's going to pop up, but you can also find it in the bare bar, but we're just going to go back and type read shape. This one here, read shape files, is actually converts shape files to GeoSun, then operates as any other reader. So we're just going to use this. I'm going to put that on the canvas, and then we're going to need a file path. So we're going to type file path. Okay. And then we need a read file, which basically says, if you hover over it, empty Boolean parameter. So we need a Boolean toggle, which basically toggles between true and false. And we're going to set it to true so that it knows to run this component. Now, since it's orange, that means that it's not working yet, and that's because we haven't set the file that it needs to read. So we're going to right-click on File Path and set one existing file. Then we're going to go to our downloads, to the unzipped folder that we unblocked. And if you move this here, you're going to look for the .shp file. That's a shape file, and open. And it's going to take a second, but now it's working. And you might be wondering, where is it? Because it's actually set to a coordinate system within Rhino. So we're going to click on the scroll wheel on our middle mouse and go to zoom. That's going to show you where it is in your Rhino window. And you want to keep it here. You don't want to move it because we're going to add more layers of information. We want them all to be in the same coordinate system. Now, you might be noticing that these are actually points and they're not connected. So we're going to need to connect them using a polyline. It also comes in with the full length of the contours that are extending past your little block that you've chosen, but we're going to trim those out after. And remember, if I click, it's going to know that I'm selecting it. If I'm not clicking, and I also can't select this because it's not baked in yet. So what we're going to do is we're going to convert these points to polylines. So we're going to grab a point component. We're going to plug that into features. Now, both of these are showing us the same thing, so I can turn this off. And I just clicked on my scroll wheel and turned preview off. Then we're going to grab a polyline command. We're going to plug point into vertices. And now we can turn off points. Now we have our polylines. They are still not baked in. They're still part of Grasshopper. Okay, so now that our polylines are here, we just need to move them to their accurate elevation. So as you can see, they are flat. And what we're going to do is move them based on the data that comes with the data set that we downloaded. So we're going to need to move these polylines. First, I'm going to group these just to keep everything organized. I just dragged a window over these components, clicked my scroll wheel, and selected group. To name a group, you're going to click the group, right-click on your mouse, and there's a little kind of like hidden text box here, but you can click on that and just maybe write read contour shapefile. Great. Really important to keep things organized. You can also, I haven't talked about this yet, but there's these things called panels, which we're going to use in a little bit, but if you type panel, you can double click on it to edit information, and it also can tell you things about some of the, it's going to take a second because that's a dense component, but it can tell you things about what's coming out or into a certain component. Okay, I'm going to delete this. Actually, to unplug something, you can press Control and reattach it, or I guess unattach it. What I was going to say is that you can write a note in here. So you can write here, we are using this component to blah, blah, blah. And you can add this to your group by holding Shift, making sure you select this, hold Shift, right click, and add to group. And that way you can keep notes about what's going on so you don't get confused later on when you look at it and you want to use it again and you have no idea what's going on. But I don't need this right now. Okay, so back to moving these contours, we're using this move command, but as you can see, it needs a geometry to move and it needs a motion to use to move. So our geometry that we're going to move is going to be our polylines. Now automatically, it's moving the geometry by 10 in the Z direction because it's X, Y, Z, so it's 0, 0, 10, so it's going up 10, but we're going to change that value. And as you can see, we have both of these previewed on, so we can preview this off so we can just see our new moved geometry. And what we're going to use to move these to the accurate elevation is use a unit Z component. And that's going to be plugged into motion, so we're moving it up by a factor in the unit Z. But the factor is going to be the attributes, which are a list of all of the elevational info that goes along with each polyline. So we're going to plug that into the factor. And as you can see, it's slight, but it's definitely there, which is great. And that's it for that component. So let's group this and call it move to elevation. So I'm going to now trim off and make a surface out of these polylines. So I just need to go back and remember where it is exactly that I took this from for any distinct indication of where I am here. Looks like there's this square. It's better to cut off not enough than too much. Now, where is my square? Here. That was pretty easy to find, actually. Let me just... Looks about right. Okay. So I'm going to make a square. Actually, first things first. Let's just go ahead and save this. I'm going to save this. I'm going to make a new folder. And I'm going to call this whatever. You can call it your site Grasshopper. You want to save both of these. Okay. And I'm going to make this window smaller so I can see my layers. So I'm going to make a line work layer. I'm just double clicking on layer 1 and I'm typing line work. And then I'm going to make a 1 meter contours layer. I'm going to drag this into the line work layer to make it a sub layer. And I'm going to bake these contours onto my layer so that I can trim off the excess fat. So I'm going to right click and I'm going to select bake and make sure that 1 meter contours is selected. You can also group these if you want to. That can be helpful when you have a lot of different shapes going on, but we're just going to leave it ungrouped and press OK. So it's taken on the color purple, which I mean, we can leave it at purple for now. I'm going to turn this off. So now these are directly editable. So I'm going to make a square and I'm going to call it bounding box. Make sure that's in my line work layer. And use a rectangle here. Maybe just do that much. If you want to make sure that your contours are coming in at the right elevation, you can go to your front view and zoom in. And as you can see, they are all, if I measure this, one meter apart. You can see at the bottom here it says 1 meter. So that's what we want because we asked for 1 meter intervals. My scroll is getting a little bit messed up and that is kind of finicky to scroll around with. So I'm just going to click this bounding box and type Z for zoom and S for selected. And make sure that this is kind of refreshed to zooming in to this bounding box area. So let's trim off the excess fat, shall we? We're going to type TR for trim. Cutting object is going to be this square. We're going to cut everything around this cutting object. Select objects to trim. You can just go and see if there's anything left here. And that's good. Great. So now we're going to make a surface using these contours. Since they are at an elevation, we can make a surface out of them. What we're going to do is we're going to type patch. It says select curves, point-to-point clouds and meshes to fit the surface through. So we're going to select all of these and press enter. Now these are our options for patching this surface. Basically, U-spans and V-spans, you can kind of think of it as like a grid. So if the X and the Y represent the U and the V, how many columns or rows you have is how many U and V you want to have. So the more that you have, the better looking your surface is going to be, but also how longer it's going to take to process. But if you want it to be really accurate, you might want to do something like, I think 50 might be the max. I think 100 is the max, but I would probably stay with something like 30. You can always change it later. And I'm going to just do, I don't really know what stiffness means, but I'm going to do 5. And okay, it's going to take a second here. That's why we save it, just in case it crashes. Okay, now I'm going to go into shaded mode. And that worked pretty well. So you can see it looks like the surface is hugging the contours pretty well. Obviously, the higher UV you give it, the more accurate it will be. But this is going to work for what we need. And I am having a hard time looking at this blue, so I'm going to make it light gray. Great. And some of the contours, it's not fitting perfectly because you can't see, you can kind of see where the contours hide underneath the surface a little bit, but for the majority, it's pretty good. So we'll leave it at that. Now to make this a box, which is not necessary, but I kind of like it when it has a nice box finish, is you can just select the surface. Actually, we're still trying to use this. I'm going to press escape to exit out of that command. Select the surface and extrude surface, SRF. You can kind of do it however much you want. I'm going to go with just that for now. Then we're going to go into our front view. And I'm going to Z for zoom and E for extents. And I'm going to take a line. I'm going to make sure that my ortho is on so that it's a straight line. And I'm going to cut it off just like that. Then I'm going to use the trim command, TR. My cutting object is this line. Press enter. The objects to trim will be that, so it's a nice blunt edge, and then I can delete this. Then we're going to go back into perspective, select this surface because you can see it's kind of like got a hole in it, and you can type cap. Now it's a nice smooth box. And I still have my surface on my bounding box layer, which I don't really want, so I'm going to make a new layer called 3D, surface. And I'm going to make sure that both the box and the surface are on this layer by right-clicking on that layer and change object layer. Great. Okay, so the next thing we're going to do is add buildings to this, and we're going to do that kind of the same way we did this. It's slightly different. We're using a different plugin, but it's pretty easy as well. We're going to go back to our Open Data Portal, and we're going to type building footprint. And it should come up somewhere called Building Footprints 2009. Now, if we go to the table here, we see that this has a lot more information than the contours. There's a ton of data here for each building. They've each got an ID. They've got a elevation, a slope, a roof type. There's a lot of data in here. So we're going to export just a short little amount of it, kind of the same area that we did before. I don't actually remember where I took this polyline from. You might want to take a screenshot so you remember, but the more the better, I guess, and we can always delete. So that should be good. Export, make sure to convert this to EPSG, and we're going to download only the 442 selected records as a shape file. Okay, once we're in our downloads folder, we can navigate to our building footprints, right click, properties, unblock, apply, okay, and extract these. Great. So they are right here. Okay, now in Grasshopper, we are going to use a different component, and it's called ImpEdit, which basically import and store shapes. This is from the Heteroptera, I believe. Oh no, this is from the Edit plugin. And again, we need a shapefile path. So we're going to grab a file path. And we need a true or false, which is a Boolean toggle. You can also copy and paste the Boolean toggle. Now we need to set one existing file. So that's right click on file path, set one existing file. Now we're going to navigate to our downloads and our building footprints 2009, the one that is unzipped, and select the shape file. Great. Now this one doesn't show up, I don't believe, because it hasn't converted the shapes into like actual polygons yet. Maybe it is here. Let's see. We turn the surface off. No, they're not here yet. Okay, that's fine. Let's turn these off for now. Okay, so the next thing we are going to do is use another add-it component called Dataviz add-it. Visualize spatial and non-spatial data. So basically this imports the file. This allows you to view it. And we're going to plug shapes into shapes. And we're going to plug features into get value of feature. And then again, we need a true or false. You can copy and paste it, or you can type Boolean toggle. And it's set to false, so you just double click and set it to true. And there we have it. Okay, so you know what? Not bad, my estimating. I would definitely take a screenshot so you know where to take your box from on open data, but you know, it's not bad. It's not bad. It'll do for my fake model. We're going to take a look at what's coming out of the features by grabbing a panel and plug in features to the panel. So this is what we are kind of looking at on the open data website. So it has basically, these are called index numbers, and I'm not going to go into all the data management stuff because it's still really confusing to me, but basically these are called branches, these are called index numbers, I think. But basically you can grab one of the index numbers. For example, if I want to grab number 7, then I can get the data of each roof type for each shape by choosing number 7 out of this list. But we're going to choose to start the base elevation in meters, which is index 5, to decide to tell Grasshopper how high to put each of these polygons above sea level, because it's still kind of geolocated in here. Okay, so let's group these and call it import building shapefile. Now we want to move these polygons. We're going to type a move. We need a geometry and a motion. The geometry is going to be our polygons. You can see it automatically moves them, whatever the default is. I'm going to preview that off. We need to move it by the Z vector. So we're going to type unit Z. It's going to be the motion in which we move. And to get the 5th item in this list to move it by, which is the elevation, we're going to type list item. Okay, and we're going to plug that into factor. And it needs a list and an index. The wrap doesn't really matter for this, but we need a list and an index. So the list is going to be the attribute values. And by default, it's set to 0, but we want to set it to 5 because that is the index that we want. So we're going to double click on the canvas and type 5. Plug that into index. And as you can see, it's kind of hard to tell, but they are all at different elevations. I guess I picked kind of a bad neighborhood that, I mean, there's not that much slope, but that's fine. Okay, great. Which way does this go? This way? This way. Okay. So let's group these now that they are moved and name it move to proper elevation. And the last thing we're going to do is extrude these buildings to their accurate height. So we need to extrude. So we need a base to extrude from and a direction to extrude in. So the base that we're going to start with is the geometry here. And we're going to extrude in direction, you guessed it, unit Z. Okay, and then it's automatically set to 1. So you can see these are all extruded by 1 meter. But we want to use the max height in meters from index 11. So to do that, we're going to grab a list item. The list is going to be our attribute values again. Oh, okay. And our index is going to be 11. Great. So as you can see, all these buildings have been extruded by their somewhat accurate building height, which is really cool. But they are kind of like weird open fences. So we're going to cap these holes using cap holes. B-rep is basically like a type of surface. So we're going to use these extrusion surfaces to plug into the B-rep. And we can turn off our extrusions. And we have these capped holes buildings, which is great. But they are still not like part of Rhino. So we're going to bake them. But let's group these and call it extrude building heights. And that is pretty much the end of this Grasshopper script. So let's just finish up here with Rhino. So we have a 3D surface, but we don't have a 3D buildings layer. So let's do 3D buildings. We can also make a new layer and call it 3D model, perhaps, or 3D, and put the surface and the buildings in that layer. And I'm going to make my buildings lavender. It's pretty. Okay, and so we're going to go to cap holes, right click, bake onto the 3D buildings layer, and okay. Now I'm going to turn this off, the preview, and we have these editable buildings. So I'm going to go ahead and like delete these ones. Oh, so our something's still turned on here because this is not editable, and it's also red, so nothing's selected. So I think it's probably the building footprints, which is true. So I'm going to actually bake these in just in case I want them. I'm going to make a new layer, sublayer in this line work, and I'm just going to call it building footprints. And I'm going to make them orange. And I'm going to right click on my moved to the proper elevation building footprints and bake them onto the building footprints layer. And yeah, that's good. And then we can turn this off. Great. So I can delete these now. And these ones are kind of like half on, half off. So I'm just gonna like leave them for now. But what you could do is trim them, I'm pretty sure. Let's try that. Let's go TR for trim. Select cutting object is going to be this. And let's try to trim. There we go. Now you only need to trim things that intersect. These ones you can delete on their own. I like to typically work in perspective. That's what I keep kind of going. But I keep forgetting. I think it was this way. Okay. Great. So now let's turn back on our contours and our surface. And there we have it. A very gorgeous model that you can use to create a section cut through, and then you can get the accurate elevation of the buildings in your section and the accurate, somewhat accurate based on how many UV you set, what your section line is going to look like. So it's pretty cool. Let's save this. So yeah, that is all. If you want me to do more Grasshopper tutorials, I can do them. It can be really fun if maybe you have like a forest and you want to like randomly disperse tree model in there. that you don't have to click each one individually. It can randomly kind of distribute them in an area, or we can add more information on here. We can do lots more with Grasshopper, but this is really basic and I don't want to overcomplicate it too soon. This should help you out for what you need to do moving forward.